Now that we understand what physical and chemical properties are, let's take a look at physical and chemical changes. So a physical change doesn't alter the chemical composition of the sample. So in this picture right here, okay, we've got some water boiling. Now liquid water is H2O. Gaseous water is still H2O. So I haven't altered the chemical composition of that substance by boiling it. All I've done is change the state that it's in. Okay, right here, I have some iodine sublimation. So sublimation, we went from a solid straight to a gas, and then I've got some iodine deposition on the bottom side of this watch glass where I've gone from a gas straight to a solid. It's still iodine. Identity of the chemical has not changed. All that has changed is the state of matter that it is in. Okay, now whereas a chemical change, now we do get some sort of alteration. A reaction occurs. So the composition of our sample changes. We get some new properties. So fruit that's ripening, this is an example of a chemical change. And so it's easy to see if you look picture 1 of this banana up to picture 7, it's very obvious that things have changed. We represent our chemical change by these chemical equations. So going from liquid water to gaseous water, that's physical. But going from hydrogen gas and oxygen gas to water is a chemical change. So this shows kind of a molecular view of it. And then I can write this like this. All right. And there's my chemical equation showing that my hydrogen gas and my oxygen gas produce water vapor. And then you can condense that down and get liquid water. Right here, combustion of propane. So propane is a hydrocarbon. Hydrocarbon, hydro for hydrogen, carbon for carbon. So hydrocarbons are made up of hydrogen and carbon. So propane is a 3-carbon hydrocarbon. So combustion, it's burned in oxygen, and we end up forming carbon dioxide, and it's usually done at high temperatures, so we end up with carbon dioxide and usually water vapor. And then obviously that can condense down into liquid water if it cools. And so combustion of propane, this is an example of a chemical change because I'm taking 2 substances and I'm getting 2 different substances. Sometimes chemical reactions, we take 1 substance and it decomposes into 2 or more. Sometimes we have more than 2 reactants. Sometimes we have more than 2 products. But the situation is we've got our reactants, they react with each other, something happens, and we get something new. Okay, so some examples here of different types of changes. So iron rusting is chemical, boiling water, physical, burning sulfur in air, chemical. So cooking is chemical changes. So boiling an egg would be chemical. Gasoline, combusting that is chemical. What happens in our bodies when we eat and we digest food, there's a whole bunch of chemical reactions that take place when we're digesting food. If I take a saw and I just saw some wood, that's physical because I haven't done anything to it. I'm just breaking into multiple pieces. But burning wood, that's a chemical change. Heating glass to melt it and to reshape into other things, that's physical. So let's see how much sense this all makes and if we can figure out physical or chemical changes from these. So mulching leaves, okay, is that physical or chemical? Okay, so we get chemical. Milk turning sour, that's also chemical. Okay, making wine, that's a chemical process. Now what about making ice water? That's physical. Okay, beer going flat. So when something goes flat, like a soda or a beer, typically what's happened is there is carbon dioxide that's dissolved in the liquid. And when it goes flat, it just means that the carbon dioxide has bubbled off. There's no reaction that occurs. It's just that the gas that's in there has bubbled off. So that's physical. Leaves changing color, chemical. And fireworks exploding. That is also chemical. Okay, so we have physical and chemical changes all around us, not just in the chemistry lab, but all the processes around us are some sort of physical or chemical change.